All right, in this lesson, we are going to solve 3x3 systems using technology. Okay, and so for us, that means a TI-84 calculator. And so when we are using the calculator, we have to use what is called an augmented matrix. And in this case, we just focus on the coefficients. And so, for example, we have a system here, and if you don't have a number in front of the variable, there's an invisible 1. So I like to go ahead and fill in the 1s. And then you are just going to focus on each coefficient for your x's, your y's, your z's, and your constant. And so here for my x's, I have -1 for the first positive 1 for the first equation, -1 for the second equation, 3 for the third. And then for the y's, I have -6, 5, and -2. And then for the z's, I have -2, 3, and -4. Don't lose negatives. And then for the constants, I have -8, 2, and 18. Okay, and so we put this set of numbers that I just wrote in a set of brackets or parentheses, either one. So I'm going to use brackets. And then oftentimes you'll see a line where the equal sign is. And so where this equal sign is, there's a line. You don't use commas, you just write the numbers, and then the spacing tells you which variable it goes with. Okay, and so you just use brackets and then put the numbers in their places. Okay, so for number 2, my augmented matrix, starting with the X row, it's going to be 5, 3, and 6. And then for the Y column, I have 1, -2, and 8. For the Z column, I have -3, 5, and 1. Equal signs. And then constants, -27, 21, and 27. Okay, notice I'm not writing any variables, and I'm not putting any commas. No variables, no commas, just numbers. Okay, here we have some missing terms. Anytime you're missing a term, that means the coefficient was 0. And so if you want to fill in your missing terms with zeros, that'll help you fill in your matrix. You're not allowed to have any blank spaces in your matrix. Okay, and so for my X column, I have 2, 0, 0. For my Y column, I have -4, -6, 0. And then for my Z column, I have 3, -7, 4. And then for the constants, I have 42, -44, and 32. No commas, no variables, no blank spaces. The calculator has to do math with these matrices, and so no extra symbols, just numbers. That's the point of the matrix. It allows the calculator or any kind of technology to work with multiple numbers at the same time. Okay, be very careful with this next one. Notice your x's are not lined up. Okay, and so when you rewrite this system, put your x's first. So my first equation is missing the y term. So I'm going to fill in 0y. My second equation is missing the x term. My third equation is missing the y term. Okay, and so fill in some invisible ones. Okay, and so for my x's, I have 4, 0, 1. For my y's, I have 0, 1, 0. For my z's, I have -2, -7, and 4. And then for the constants, I have 23, 15, and -10. Almost wrote the z -1. No variables, no commas. Okay, for this last one, it just has x, y, and z on the left side. And so technically there's ones in front of these and then zeros in front of the others. And so this first equation would be 1x plus 0y plus 0z equals -5. 0x plus 1y plus 0z equals 2. Just putting zeros for any of the missing terms. In the third equation, we're missing x and y. We only have z equals 17. Okay, and so now when I make the matrix, my x's are 1, 0, 0. My y's are 0, 1, 0. And then my z's are 0, 0, 1. Equal signs. And then the constants. Okay, and so this system in number 5 was already solved for. We have the solution. X equals -5, y equals 2, z equals 17. So there's no solving to do. We already have our ordered triple, -5, 2, 17. But I wanted you to see the augmented matrix associated to a system that's already solved for. There's ones along the diagonal and then zeros everywhere else. Okay, that's a very special type of matrix, and it's said to be in reduced row echelon form. Reduced row echelon form. And the abbreviation is RREF. Okay, and so it's a fancy way of saying that each variable is already solved for. And so you can see your solution is -5 for x, y is 2, z is 17. Just knowing that this is your x column, this is your y column, and this is your z column. So where you see the 1 is for the z, so that's how you know z is 17. Okay, and so there's actually a lot of steps involved to go from a system that looks like this to looking like this. You would do what's called elementary row operations. You can switch rows, add one row to another, kind of like the elimination process. You start eliminating certain numbers. And so what's amazing about technology in our calculators is it can do all of those operations for us. Okay, and so here's the calculator steps. And I'm going to try to show on the calculator app. I'm sure it's kind of similar to what your calculator looks like. And so your first step is to go to second matrix. Second is the blue button, and then matrix is right below math. Second matrix. Okay, and then you're going to go over to edit. And it looks like I have some stuff. So I'm going to clear my memory. Second plus 7, 1, 2. Okay, so second matrix. And then your first step is to edit. And so you're going to go all the way to the right where it says edit, and then just choose option 1 for matrix A. Okay, here they're asking for your dimensions. And so each of these have 3 rows, 1, 2, 3 rows, and 4 columns. And so we want a 3 by 4 matrix. 3 by 4 matrix. 3 rows, 4 columns. So 3, 4. Okay, and so from there, you're going to input the augmented matrix. Okay, and so for this first example, I'm going to write the augmented matrix. My x's are 1, -1, 3. My y's are -6, 5. -2, -2, 3, -4, and then -8 to 18. Okay, and so we're going to type those in, 1, and then when you press enter, it takes you over to the next column. So -6, -2, -8, and then -1, 5, 3, 2, and then 3, -2, -4, and then 18. I'm just pressing enter each time. Okay, I do a double check to make sure that I've typed everything in correctly and didn't lose any negatives. And then after you typed it in, you have to press second quit. Okay, second mode is how you quit. You need to get out of the screen and then go back to it. Second matrix. Okay, we just edited. Our next step is to go to math. So just go to the right one space in math, and you're looking for RREF. If you scroll up, you'll get there faster, I think. And so it's option B, RREF. Your options may look different, and so you're looking for RREF. Press enter. And then your last step is to press second matrix again. It's kind of like your home screen. And then just choose option 1 because that's where our matrix is, matrix A. Press enter. And so we can see our reduced row echelon form has ones on the diagonal and 0s everywhere else. And so our solution is 4, 3, -3. Okay, for this next example, we're going to do the same thing. We're going to set up our augmented matrix. 5, 3, 6, 1, -2, 8, -3, 5, 1, equal signs, -27, 21, and 27. Okay, so second matrix, that's kind of your home screen. Go back to edit, and then you can choose option 1 again and just override all your entries in what you just put in. So now I need a 5, 1, -3, -27, pressing enter each time, 3, -2, 5, 21, 6, 8, 1, 27. Second, quit. Otherwise, you're going to keep typing into the matrix, and you don't want to do that. So second, quit after you enter it, and then back to the matrix home screen. Go to math. You're looking for RREF. And then second matrix, choose option A, enter. Okay, and so this time my reduced row echelon form, I see the zeros and the ones on the diagonal. Remember, that's your X column, that's your Y column, that's your Z column. So X is -2, Y is 4, Z is 7. It's important that you don't write this entire matrix as your solution. You only care about the ordered triple. Remember, our solutions are ordered triples. And so in this case, you write your solution -2, 4, 7 with the commas. When you're writing your final solution, you do use the commas. It's like an ordered pair, but this time an ordered triple. Okay, on these next examples, I think something weird happens. Okay, and so I am going to start by writing the augmented matrix, which is 1, -1, 5 for the X column, -3, 2, -13 for the Y column, 1, -5, 13 for the Z column, and 4, 3, 8. Okay, second matrix, go all the way to edit, choose option 1. And then override your entries. 1, -3, 1, 4, -1, 2, -5, 3, 5, -13, 13, and 8. So double check, make sure all your columns are right. So 1, -1, 5. Okay, and so now second, quit. That's second mode. And then back to matrix home screen. Go over to math, look for RREF. And then second matrix, choose option 1, enter. Okay, so notice I don't have ones on the diagonal and zeros everywhere else. Okay, so my reduced row echelon form has a 1, 0, 13, a 0, 1, 4, and then a 0, 0, 0, 1. So I like to put a line where the equal sign would be. And so when you see this situation, when you don't have ones on the diagonal and zeros everywhere else, look at the last row. Okay, if you have a last row of 0, 0, 0, 1, what that equation says is that all your variables are gone on the left. You have no variables, but it equals 1. Okay, and so because that is false, not true, that means you have no solution. Okay, so anytime you see 0, 0, 0, 1, that's no solution. It's a special case. Okay, number 4 is a different kind of special case. Okay, so once again, let's get the augmented matrix, which is 2, 4, 1, 1, 2, -1, -3, -6, 1, and then 0, 0, 0. That doesn't, we don't usually have equations like that, but that's not the problem. So now, second matrix, go over to edit, choose option 1, override your entries. Second quit, second matrix, go over to math, RREF, second matrix, option 1. Okay, and so for this one, just focus on the last row when you realize something weird is happening. And so we have 1, 0, technically that's negative 2/3, but you don't need to know that. 0, 0, 1, negative 1 2/3. And then the last row is all zeros. Okay, that's the important part. When the last row is all zeros, that means you have 0 equals 0. Which is true. Which means you have infinitely many solutions. Okay, and so for this one, you would say infinitely many solutions. You wouldn't say all real numbers because remember our solutions are ordered triples, not numbers. They're ordered triples. And so you have infinitely many solutions because you have infinitely many points that would work. Okay, and so remember 0, 0, 0, 1 is no solution. 0, 0, 0, 0 is infinitely many solutions. In the other cases, you just look at the last column to get your x, y, and z.